This episode is sponsored by Ground News, a new website and app that lets you compare how major events are being covered. Head to ground.news/SciShow or click the link in the description to download the free app. This time of year, it's nice to sit around the table with loved ones. But stay safe in the leftover haze that might be about to come, and remember, good food will not stay good forever. A lot can happen to your food when it goes bad. Here is what's going on when our meals start to spoil, beginning with the obvious signs. Sometimes it gets pretty moldy.
You know when you got like 3/4 of a loaf left, and then you see that little blue-green fuzzy spot, and you're like, should I not eat? But you probably shouldn't eat it. But why? And why can I eat this, but not this? It's a moldy world out there, especially in the kitchen. And we have answers for you. Food mold, like all molds, are microscopic fungi. They grow from tiny spores that float around in the air all the time, and they're all around you at this very moment. Seriously, mold spores are between 3 and 40 microns long. Your hair is about 125 microns wide. So tiny. When conditions are right, there's enough moisture, warmth, and nutrients, the spores will set up shop. Unlucky for us, mold prefers the same kinds of temperatures that we prefer, and even the coolness of a refrigerator won't prevent mold from forming eventually. Let's say our mold has found a delicious peach on which to grow. In its early stages, the spore releases root threads of the mold fungus deep into the fruit. By the time you see the first signs of mold, those threads, called mycelia, have already penetrated the inner depths of that peach. These roots are difficult, if not impossible, to see. The signs of mold, whether it be weird fur, green dots, or white dust, are a result of the stalk of the fungi rising above or sitting on the surface of our now not-so-delicious peach. The spores that form at the end of the stalk are what give mold its color. Mold is an efficient organism, growing quickly as enzymes released by the mycelium break down whatever organic matter it has invaded. Unlike other fungi, mold digests its food first and then eats it, allowing it to grow at a faster pace. Now, you may have heard that mold isn't dangerous if you just cut away the ugly parts and eat the rest of the food. This is generally true with harder foods like apples, potatoes, onions, and hard cheeses like cheddar and Swiss, where the mycelia can't quickly penetrate their host. But I would suggest not trying to cut or scrape away the mold off of soft cheeses, berries, meats, and other produce. You may very well become ill if you eat that kind of thing. The reason is mycotoxins, poisonous chemical compounds produced by several kinds of mold. Mycotoxins are produced around the mycelium, and not only can they survive a really long time, but most aren't even killed when the food that it has invaded is processed or cooked. The molds that produce mycotoxins are mostly found in grains and nuts, but have been known to invade celery and other produce as well. One of the most dangerous types of mycotoxin is called aflatoxin, which is produced by two kinds of mold. This naturally occurring poison, which has been known to cause cancer, is typically found in field corn, wheat, oilseeds, and peanuts. In fact, many scientists believe that those dangerous peanut allergies we're always hearing about are the result of a reaction to aflatoxin, not the peanut itself. Other foodborne molds may cause less severe allergic reactions, rashes, or nasty infections. Of course, some molds don't produce mycotoxins and are totally safe to eat, notably the ones you see in some smelly cheeses like blue cheeses and gorgonzola and Stilton. These are actually created by the introduction of specific mold spores. One of these, Penicillium roqueforti, comes from the same genus of fungi used to make the group of antibiotics known as penicillin. The mold in these cheeses breaks down complex organic molecules into simpler ones, which smooths out the fibrous structure of the cheese and also results in their unique flavor and smell. But moldy cheeses are not immune to other molds, so be careful next time you're about to dig into that 6-month-old block of Roquefort.
Yeah, so don't eat moldy food if you can avoid it, except maybe some smelly cheeses. Luckily, that's a pretty easy thing to notice on your food. But what about food that does not have mold growing on it? If it has still changed color and tastes bad, what's going on?
Let's say you've got an apple, and it looks delicious, and then you bite into it, and you find out it's all gross and brown inside. Or maybe you just want to eat half an apple, so you slice it and leave the other half on the counter. An hour later, it's a brown, mealy mess. All I wanted was an apple, and now all I have is a mouthful of disappointment. What happened? Well, different kinds of cells have different kinds of enzymes, and one enzyme that's found in the flesh of fruit as well as the flesh of people, is polyphenol oxidase, or PPO. Its job is to interact with phenols, simple organic chemical compounds that can be found in pretty much everything alive. Specifically, PPO oxidizes these phenols wherever it can. That just means that it encourages them to bond with oxygen atoms, and it'll do this as long as it has access to both phenols and oxygen. Now, the oxidation of phenols kicks off a long and complicated chain reaction that ends in a protein you've probably heard of: melanin. The same pigment that controls your hair and skin color is also produced by fruits and veggies. It's what you're seeing when your apple turns brown. And actually, melanins are a lot more widespread in plant tissue than in our own tissue. We can only really produce them in our hair, eyes, and in the bottom layer of our skin, whereas plants have them practically everywhere. And the melanin that plants make serves a different purpose. So when plant cells are damaged, melanin is produced to surround and slow down any possible infection. That is why, if you've ever cut open a rotten apple, the rotten spot is usually surrounded by browned flesh. It's essentially the apple's immune response to rot. Unfortunately for us, it's also the apple's response to any kind of damage. You drop the apple on the floor, it kills some apple cells and starts cranking out melanin to protect itself. And when you cut an apple into slices and serve them with crackers and cheese, those slices are going to brown really, really fast. Because not only are those cells damaged, but they've been exposed to air, which, as you may have noticed, is full of oxygen, which allows the PPO in those cells to basically throw a big oxidation party. It'll oxidize all the phenols. That apple is going to be so safe. Except it's not going to be safe at all. You're either going to eat it, or you're going to throw it away when it gets all brown and nasty. Because those nice fresh phenols are really tasty, but the melanin, not so much. But on the bright side, the brown color in cocoa, raisins, coffee, and tea are all caused by this exact same oxidation reaction, and that actually gives those things the taste we like about them.
There must be a way, though, to prevent your apples from going bad or your other food from growing mold. Surely, we have come up with a bulletproof system to ensure that we don't eat food that's gone bad. Well, about that.
You know that horrible, sour smell that comes from expired milk? Yeah, you only need to smell it once to make sure it never happens again. Luckily, many food manufacturers put some kind of sell-by, best-by, or use-by date on their products to tell you, well, actually, they don't tell you much. These labels are mainly for quality and flavor purposes, not safety, and a lot of common foods are edible past what it says on the label. This can make it difficult to figure out what you can eat and what needs to go in the compost bin, but understanding what's happening chemically when foods go bad, both before and after those dates pass, can help you out. A product's real expiration date is tricky to predict because it can be affected by everything from the sanitation of the factory to the temperature of your fridge, but a lot of it depends on what kind of food you're buying. Produce, for instance, can become unsafe anywhere from hours to weeks after you buy it, a huge variation most labels don't account for. Most of this has to do with when it gets moldy, and not about things like brown spots. Although those don't look pretty, they're harmless. Mold, meanwhile, can actually hurt you. Some strains produce substances called mycotoxins, which can cause everything from skin infections to internal bleeding and death. And because produce is such a water and nutrient-rich home for mold, it can start growing as soon as 24 hours after you bring your produce home, and it grows even faster in warm temperatures, like on your sunny kitchen countertop. Extending the shelf life of your produce is pretty easy, though. Just throw it in the fridge. Chemical reactions happen more slowly at cold temperatures, so it takes longer for mold to grow and reproduce in there. But it will grow eventually, and when it does, whether it's after a day or a few weeks, it's time for the compost bin. Dropping the temperature might be a great trick for a lot of food preservation, but if you want to really push back the expiration date, you have to kill bacteria before letting them reproduce. That's not easy with produce, but it's exactly how we treat milk. According to the label, milk is usually at its best for around 2 weeks after you buy it, but depending on the kind you buy and how you treat it, it could really expire a few days later or earlier. Traditional milk goes through the process of pasteurization, a heat treatment process that denatures enzymes in living bacteria and renders them harmless. And it does a good job, but it's not perfect. Some of those bacteria survive pasteurization, and over time, they convert the sugars in milk into lactic acid. That's what gives spoiled milk that sour smell. Normally, this process takes a couple of weeks, and typically it's still drinkable for around 5 days after the sell-by date. But if the milk gets exposed to slightly warmer temperatures somewhere along the shipping route, or if you run your refrigerator a few degrees warmer, it can spoil faster. And while you're probably not going to catch anything life-threatening from drinking spoiled milk, you can catch some brutal food poisoning. The good news is, it's easy to tell if milk's gone bad. Just give it a whiff and take in that lovely lactic acid smell. Finally, while heat treatments are awesome for getting rid of bacteria in milk, You'll need a different strategy for meat. Typically, the best or use-by dates on these products is for a week or so past purchase, but while it's often safe past then, it doesn't last for that much longer. That's because meat is a prime breeding ground for bacteria. It's a wet, nutrient-dense home with all kinds of fuel sources. For a few days, these bacteria won't cause you any trouble because there aren't that many of them, but over time, they'll multiply. And that's when you get problems. Bacteria, like Pseudomonas or lactobacilli, feast on the meat's surface, where there are free-floating sugar molecules and lightweight compounds to nom on. Some of these bacteria can make you sick, but they do at least announce their presence. As they break those compounds down, they leave behind some nasty-smelling byproducts. These have all kinds of shapes and compositions, but they all fall into a category called volatile organic compounds, or VOCs. Normally, these VOCs smell like rotten meat. And because you find them when bacteria have been chowing down and multiplying, there's a pretty strong sign your meat has gone bad. Besides the smell, you can also probably tell your meat has expired based on how it looks. For example, VOCs like hydrogen sulfide can convert the natural muscle pigment in meat into something that looks more green. Typically, all this happens a few days after the use-by date on that sticker. But if you notice any of those funky smells or a little slime on your beef, it's time for it to go, no matter when it happens. Food science can be tricky, and those ambiguous labels don't always help. Knowing a little bit about how and why food expires can help you keep your fridge full for longer, but if you're really uncertain, it's okay to play it safe.
So there's a lot of information out there about food and leftovers. In fact, there's a ton of information on the internet in general, and it can be hard to stay up to date with the latest science news in today's world. But if you're interested in seeing how different media outlets cover news across the political spectrum, you might want to check out today's sponsor, Ground News. Ground News is a new website and app that lets you compare how major events are being covered. You can even follow the issues you care about, like science or health. You can check out every side of every news story by going to ground.news/SciShow or click the link in the description to download the free app. Now, let's jump back in to talk about what you can do with spoiled food, like composting. If you have a composting service at your work or school, you might have noticed an odd pattern. They can take as many apple cores and paper towels as you care to give them, but they will not accept meat or dairy. And if you compost at home, you might also avoid adding those things to your pile. But the problem isn't that it's hard to break those things down. The problem is that it's easy. Too easy. Composting is a way to convert things like food scraps and yard trimmings into fertilizer instead of sending those things to landfills. So it might seem annoying that you can't toss all your leftovers in, and it turns out you can if you're careful. Some of the problems with composting meat are practical. It can attract pests, and you probably don't want to have to fight off a bunch of rats and raccoons in your own backyard. Plus, some folks worry about disease-causing bacteria being able to grow in home compost piles. But the solution there is just to make sure the pile reaches a high enough temperature to kill those pathogens off. Temperature is a super important factor in composting anyhow, one any home composter should be keeping an eye on. But the weirdest reason it's tough to compost meat and dairy is how delicious soil microbes find animal protein. And even though composting is all about getting friendly soil organisms to break stuff down for us, we don't want them to get too excited. Good composting relies on the ratio of two elements, carbon and nitrogen. Carbon makes up the chemical foundation for practically all of life's favorite molecules, including proteins. But proteins also contain a lot of nitrogen, which means that animal products, which are more densely packed with proteins than veggies, contain more nitrogen. Experts have determined that the best ratio of carbon to nitrogen in compost is somewhere between 20 and 30 to 1. Veggie scraps are generally right in that sweet spot at 25 to 1, but something like a chicken carcass is more like 5 to 1. And when bacteria see all that nutritious nitrogen in a compost pile, they go a little bonkers. They start to grow really fast. That uses up oxygen, and when the bacteria use up all the oxygen in the pile, that favors the growth of other bacteria that don't need oxygen to live. Basically, the pile switches to anaerobic or oxygen-free decomposition. And the chemical products of that process are very smelly, like hydrogen sulfide, which smells like rotten eggs. So if you just casually toss your meat and cheese into your compost pile, you'll probably end up with a slimy, putrefied mess instead of lovely fertilizer. And putrefied compost can actually contain chemicals that are toxic to plants, though you might be able to salvage it if you dry it out and try again. To avoid taking those extra steps, expert composters might add extra wood chips or paper products to the pile since they have a lot of lignin, a tough component of plant cell walls which doesn't contain any nitrogen at all. Bacteria can still eat lignin-packed materials, so they just slow down those overly enthusiastic microbes. And if you really want to compost meat at home, you could plan ahead. One way is to use a method known as Bokashi, which relies on anaerobic processes on purpose. Basically, you add cultures of friendly anaerobic bacteria instead of the bad smelly ones. Once things like meat scraps have been treated with the Bokashi method, they can be added to a compost pile with less risk of the whole thing going stinky. So just because your municipal compost service won't take meat, that doesn't mean it can't be composted. You just have to know how to rein in your bacterial buddies. Composting food can put it back to use, but for your own sake, use the appropriate tools for the food you have. Now that's a great way to take care of food that's already gone bad, but how do you proactively take steps to prevent your food from rotting, or at least prevent your food from unplanned rotting?
So fermented foods have been around for pretty much forever, but they seem to be even more in fashion now. The rainbow-colored selection of kombucha tea, the fridges full of miso and kefir and tempeh and sauerkraut. You can't toss a gluten-free cookie without hitting a live and active cultures label. Those live and active cultures are actually a thriving community of probiotic bacteria living in the container. Probiotic bacteria literally just means good germs. By definition, microorganisms that instead of giving you strep throat or gonorrhea or something worse are beneficial and maybe even make your life possible. These bacteria help balance out the microflora foam party going on in your intestines and keep pH levels in check. They block bad bacteria from latching onto your intestinal walls, help you produce digestive enzymes so you don't get all bloated after that third burrito, and increase your nutrient uptake. And they do it basically by eating our food for us. Essentially, the foods that these microorganisms feast on and the foods that we buy them in undergo a chemical transformation that's basically controlled rotting. So if you prefer, you could think of probiotic foods as being partially rotten or pre-digested. You probably don't prefer that. Like it or not, though, they're what turn milk into yogurt, soy into tempeh, and cabbage into sauerkraut, a special kind of fermentation. Fermentation is a type of anaerobic respiration where microorganisms feed on organic compounds, often sugars, to get the energy they need, but they do it in the absence of oxygen. While most of us are familiar with the fermentation that turns hoppy water into beer or grape juice into wine, those kinds of cultures are usually yeasts, and they produce alcohol as a byproduct. The cultures in probiotic foods, by contrast, are usually bacteria, and they break down sugars to make lactic acid. This is known as lactofermentation, and the star of the show here, and by here I mean your intestines, is Lactobacillus acidophilus. It's a bacterium that lives naturally in your gut, but its numbers can dwindle if you've been taking antibiotics, had a nasty gastrointestinal bug, or if your innards are just generally bad bacteria farmers. What's particularly excellent about lactobacilli is that they're salt tolerant, whereas various bad bacteria, like the kinds that spoil our food and make us sick, are not. So by, say, submerging cucumbers in salty water for a few days, we can keep out the bad germs that would rot our cukes while still courting the good bacteria, which partially digest those vegetables, converting lactose and other sugars into lactic acid and turning the cucumbers into pickles. So remember, fermenting is not the same thing as pickling. Non-refrigerated foodstuffs you find at the market, like those jars of pickles and sauerkraut getting dusty on the shelf, were just dumped into vinegar and never fermented. Fermented foods, many of which have that live and active cultures label, are a lot easier to digest precisely because they've been partially digested for us, and in a manner much cleaner than, say, a mama bird regurgitating a mouthful of worm mush to her babies. So in addition to eating that semi-decomposed cucumber, you're also ingesting the friendly bacteria that so helpfully started the digestion process. That's the double benefit of lactofermentation. We spent a lot of time and effort trying to limit our exposure to bacteria, but the fact is we would die without them. Your body, glorious shrine to hygiene that it may be, contains about 100 trillion bacteria. That's more than 10 times the number of your own cells that you have in your body. Which sort of means that you're more bacteria than you are you.
Having bacteria pre-digest your food is one way animals protect themselves from bad food. But there are some handy alternative methods for dealing with poisonous food out there.
A particular smell or taste or the sound of a Nickelback song. In the right circumstances, any of these things might trigger your gag reflex, or worse, your emetic reflex, otherwise known as an epic case of cookie tossing. For humans, gagging has been a very handy strategy for not choking to death, especially for babies, who often literally bite off more than they can chew. And puking might not be pleasant, but it can be a useful way to get rid of bad stuff in your system. But despite its usefulness, not all animals gag or vomit, but they do have other handy tricks to compensate. And spoiler alert, some of them are kind of gross. Horses, for example, can't really vomit because of the way their digestive system is arranged. You're probably familiar, though hopefully not too familiar, with how puking works in humans. It normally starts with a gag reflex, which constricts the back of your throat. Repeated constrictions then trigger contractions of your abdomen that force stomach contents back into your esophagus. This eventually propels your lunch out of your mouth and hopefully away from any friends or loved ones. Horses can't really do that whole forcing food up the esophagus thing, though, because of their esophageal sphincter. That's the valve that makes sure food stays in your stomach once you swallow it, and it's much stronger in horses. Plus, the angle between a horse's esophagus and its stomach is a lot like a bend in a hose. Vomiting builds pressure on the stomach side, and to alleviate it, you either have to unbend the hose by rearranging the horse's insides, or try to add enough pressure to force vomit through the bend. But in this case, odds are the animal's stomach would burst before anything got into its esophagus, which is why, for horses, ejecting toxins via the mouth is very rare. Instead, they flush them out the back door. The vast majority of nutrient absorption happens in the horse's intestines and colon, and diarrhea is a quick way to clear these organs before they absorb something that seems dangerous. Rats also can't lose their lunch, partly because of a similar valve problem to horses, and partly because their muscles can't physically make the movement that would get the food up their esophagus. Instead, a rat that thinks it's been poisoned will try to cure itself by eating other things, a behavior known as pica. Rats are not known for being picky eaters, except when they're nauseous. Given the choice, they'll ignore soils and pebbles in favor of kaolin, a kind of clay. The more nauseous researchers make the rats, the more clay they'll eat, and rats given antiemetics, medications that reduce nausea, will go right back to eating rat food, otherwise known as pizza in the subway. Clay eating seems to be a rat's attempt to self-medicate. Biologists still don't know all the details when it comes to how the clay helps, but the metal ions in the kaolin bond well with some toxins, meaning that the rat doesn't absorb them. Then there are the animals that don't necessarily need to vomit, but they can if they want to, so they use it as a defense mechanism. Turkey vultures are particularly good at this. Vultures eat rotten meat, which can contain hundreds of species of potentially harmful bacteria, so if they had to hurl to get rid of that bacteria, they'd hardly ever be able to keep a meal down. Instead, turkey vulture guts are extra acidic, which kills off most of the bad bacteria before it has a chance to hurt them. They've also evolved a tolerance for certain species of bacteria that can cause massive die-offs in other birds. Those bacteria help them with digestion now. But turkey vultures are still physically capable of vomiting. They just do it on purpose, aggressively. Up to 3 meters. It's a super effective strategy. Most people and a lot of other animals hate being vomited on. Plus, turkey vulture vomit can be especially acrid and corrosive. A diet full of decaying animals will do that. So if you ever encounter an angry vulture, you might want to back away.
Now, after watching this compilation of SciShow videos, you might be wishing you had extra acids in your gut to combat all that rotten food that now seems to be lurking in every unsuspecting corner. But we usually do pretty well for ourselves by avoiding it and vomiting it out of our bodies when we need to. So remember what you learned today when sifting through your leftovers after the holidays, and enjoy them while you can. Thank you for watching. If you liked this video, you might enjoy our compilation of food before it goes bad.